In this lecture, we're covering fundamentals in harmonics and how you set frets on a guitar or something like that, and the difference between some of the instruments in terms of their harmonics. Um, and so, what all we're going to be talking about? We've got fundamentals in harmonics, scales. We're going to go over our standard scale that we use in the West and what it means, string instruments and frets, and then beat frequencies. We'll talk about that for a bit. Um, so we know for a string instrument, or for a string instrument, or for a wind instrument open on both ends, that the fundamental is simply twice the length of the wavelength of the fundamental is twice the length of the resonant length of the instrument, and that for instruments closed on one end, the fundamental is 4 times the length of the resonant instrument. So what does this say about the harmonics for those two instruments? You know, the string instruments and the wind instruments open on both ends start off at the same place, but the wind instruments closed on one end start off in a different place. So what does this say about their harmonics? Well, we're going to talk about the resonant length of the instrument L, harmonic number N, which goes from 1 to whatever, but practically, 1 to 4 or 5. You can get much higher harmonics, but actually trying to play them is different. You're going to get energy out there. You're going to get energy across the spectrum, but mostly in the harmonics. Um, the wavelength of the nth harmonic is lambda n, frequency of the nth harmonic fn, wave velocity, velocity of sound, VW. All those you know. So if we look at these string instruments and wind instruments open on both ends, in terms of the length, the resonant length, right? In terms of the resonant length, the lambda n, the length that resonates, or the wavelength that you're at, goes as 2L over N. And so it goes as basically as 1 over N. So we've got 1, 1/2, 1/3, 1/4, 1/5. If it's a wind instrument closed on one end, and this formula looks a little bit more complicated, but all this really says is in the bottom, you always have odd numbers. So you have 4L over 1, 4L over 3, 4L over 5, right? So while up here we go as 1, 1/2, 1/3, 1/4, 1/5, down here we go as 1, 1/3, 1/5, 1/7, 1/9, 1/11. And you can see that's a very different distribution of harmonics because you're missing every other one. And of course, for everything, frequency is wave velocity over the wavelength. And we're, to kind of look at this, if you're on a closed-end instrument or you're these orange dots, and you can just simply see that the distribution is different, which is one of the reasons that these classes of instruments sound different from each other because they have a different distribution of energy and the harmonics back to strings and flutes, right? You're at 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/7. Trumpets, clarinets, saxophones, tubas, you're at 1, 1/3, 1/5, 1/7, 1/9, 1/11. And so you just have a different distribution of the harmonics in these two different classes of instruments. And that's a fundamental part of why they sound different because and why you have to work on the fingering holes different. Now in this section we're only going to cover strings, which strings and flutes are similar, but they're different. Strings and flute are similar but different because you can't play a harmonic on a string directly, while you can choose to change the length of you can choose to overblow on a flute and resonate a harmonic that's not the fundamental. Um, you don't want to do that with your strings, then you're just creating a really bad twang. Um, if we look at scales, because all of this is in the context of some scale, and the standard 88 key scale is what we're going to look at, standard in the West. Um, it's changed over the years exactly where it is, and so if you have an antique instrument, you'll notice that it's designed for a slightly different set of frequencies than modern instruments. And we can argue about why the changes, and we can argue about, you can go through the history of that if you want. There are even conspiracy theories, because we can have a conspiracy theory about anything. The conspiracy theories aren't true. This is just a progression in technology as times have changed, and in some point in the materials being used. But let's think about the standard 88 key keyboard, um, which these are octaves marked off from C to C, um, and you know, and one of those things that's um, uh, non-intuitive about the keyboard is we talk about middle C, and that's your home position, but we reference all the frequencies to A4 right here, 440 hertz. All right. Um, Now, on a standard scale, when you go from um, uh, C1 to C2, you're doubling the frequency. C2 to C3, you're doubling the frequency. C3 to C4, you're doubling the frequency. When you go down, you're cutting it in half. And so our ear hears a doubling of the frequency as a change in by an octave. Now, this is one of those things it's in the physics, right? You've doubled the frequency, it's in the physics. And so if you look across music in every culture, whether it's Western Europe, Middle East, Far East, we disagree on the notes that go in between, but we all agree on what an octave is, because an octave is in the physics, right? It's in the physics. The other thing we all hear, and we all hear the same, are fifths. And a fifth is really a multiple of 3. So if I go down here and I multiply by 3, I end up at A, B, like, whoop, where are we? C, D, E. We're ending up E4, right? End up at E4. If I start, sorry, let me start down here at A, right? I start down here at A. I multiply by 3. I end up um, at E, right? So A to E, a 3 to E4 gives me a fifth. And then when you want to think of what does a fifth sound like, you have to think of the Wizard of Oz and O, O, right? So the fifth comes out of multiplying down an octave by 3, and that gets you the fifth for the octave you're in. Across multiple cultures, we all have the same fifths, again, because it's a simple multiple of 3, and we all hear that the same way. So the Western scale, one of the things I'll point out, this is all about factors of 2, which is a clue that the actual base we're working in here is base 2, not base 10. All right, we're working in base 2. So if we move to the math behind this, and we take 440 hertz, which is our 49th key, right? It's our 49th key. And when we look at it as our starting position, then the frequency for any key is this formula right here, F sub n is 2 to the 4n minus 49 over 12. Now, in base 2, or let's look at it in log base 2, we are actually dividing the frequencies out evenly on our scale in the log scale. They're distributed unevenly in the frequency scale, but when you take the log of the frequency, they're evenly spaced throughout. And it's because our perception a frequency is logarithmic, not linear. And so when you take the log of our frequencies, you get evenly spaced frequencies throughout the keyboard. And so if you wanted to calculate the frequency for any key that it needs to be, it's this formula right here, right? And if you want to calculate what it would have been on an old keyboard where it wasn't 440 hertz, but some other frequency for A4, you just change that number right there, and you've rescaled the whole keyboard. If we solve for key number, right, and we want to say, oh, I need frequency whatever, we can stick it into this formula for the key number, and we'll get a key number out. Now, if you're just picking a frequency, the odds that you're going to get an integer key number are low, so you got to think hard about that and adjust that, right? But on the standard Western scale, we have 12 notes in an octave, and they're evenly spaced in the base 2 log domain. And you got to think of it, we hear on a log scale. And one of the reasons we hear on a log scale is that gives us a much broader dynamic range than if we did not. We actually see light intensity on a log scale as well. There are a number of things that we perceive on a log scale because it gives us a much larger dynamic range than we would have if we were linear. And if you wanted just a list of all the frequencies here, and the black boxes are the black keys on the keyboard, right? So here's your standard 88 key keyboard, middle C, all right, and I've repeated, here you get C8 and a C6 to C8 and repeat C6 at the top, just so you're covering the full 2 octaves. And then down here, you know, the lowest note I've ever sung, and it was after a lot of let me get where a lot of practice. I was singing a lot, singing bass a lot. I think the lowest note I've ever hit was right here. Oh, did not mean to change all of that. Right here at B2 flat. Um, and and it was kind of interesting because it didn't come out of, the sound didn't come out of my mouth at that point. The sound came out of my chest. So, string instruments and frets. Where are we on time? All right, I'm going to pause here and we'll pick up again in a minute.